Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on proportions. And note, this is designed to be viewed after confidence intervals and hypothesis testing on the mean. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. And let me pause here to also mention that we've had to re-record this video, part 3 of 5 and part 4 of 5 of these 5 videos. So there may be fewer bells and whistles, and they may not sound exactly the same. There have been a couple of years since I've recorded these, but I'm going to record just this part 3 and part 4 again, but I hope that they'll be close to the same. Okay. We will now learn how to create a confidence interval for proportion. Confidence intervals on the proportion, and we have a couple of assumptions. One is a simple random sample, and that X is binomially distributed, and that the normal approximates the binomial. And in the previous slide, or the previous video, we talked about how to check for that, and Mrs. Borlaug uses n times p is greater than or equal to 5, and n times q is greater than or equal to 5. And we also mentioned that your teacher may use an alternate method. That method could be n times p times 1 minus p is greater than 10, or n times p times q is greater than 10. P or Q, we will use P hat and Q hat here as estimates. We have the formulas. The formula is E equals Z alpha sub 2 times the square root of P hat times Q hat over N. And we have P hat plus E equals, and P hat minus E equals. So we're now ready to do our example. Our example number 2 is a restaurant randomly selects 150 customers who order hot dogs. 123 of these customers order the hot dogs with mustard. Construct a 90% confidence interval on the proportion of customers who order their hot dogs with mustard. So now we still have that problem in front of us, so we can follow the following steps to find the problem. We can find X in P hat and Q hat. Notice as we read the problem that it gives us in the problem what we need to do. We can find the construct. Well, I thought I could do it here. Highlighter. Yeah, there we go. Construct. Well, maybe I can do it over here. Construct. Well, I don't know how to do it because apparently I can't use the highlighter. There we go. Construct a 90% confidence interval on the proportion. Apparently I have to color it in. Okay. I can use something there. So I can, and then now I can use the pen as well. Now I'm a pen. So we need to find X, N, P, and Q hat. So then the step 2 will be to check to see if the binomial can be approximated, and we will use the n times p greater than or equal to 5 and n times q greater than or equal to 5. Step 3, we will find the upper and lower confidence limits by first finding the error and then adding the error to our p hat and subtracting it. And step 4, we will write a sentence for our answer. So let's do those steps. Let's go back and do step 1, and let's label our X, our N, our P hat, and our Q hat. Our X would be the number of items with mustard. So there, as we read the problem, and I'm going to leave it as a pen, we have the restaurant randomly selects 150 customers who order hot dogs. 123 of these order with mustard. Yeah, that looks ugly, but you see the issue there. So X is the number with mustard, and N would be the total number sampled. P hat would be the estimate of the proportion with mustard, and Q hat would be the ones without mustard. So we know in words what these mean. And then next, we would then fill in the numbers. 123 have mustard. We totaled or sampled 150. The estimate of proportion with mustard would be the part out of the whole, which would be 123 over 1 divided by 150, which would be 0.82. The estimate without mustard would be 1 minus 0.82, which would be 0.18. Step 2 is to check to see if the binomial can be approximated by a normal distribution. So that's where we're going to check n times p and n times q. N is 150, so that would be, and again, I'm sorry, I missed a step there. I should be looking ahead. Since we don't know P or Q, we will use P hat and Q hat as estimates here. And so that would be 150 times 0.82, and that gives us 123. And that is greater than or equal to 5, so we can put a big check by that. And 150 times 0.18 gives us 27, and that is also greater than or equal to 5. It also gets a check mark. Since both of those are greater than or equal to 5, step 2 is complete, and we can proceed to the next problem. If that is not correct, then we stop here, and we cannot use the normal distribution to approximate the binomial. Since it is, we can proceed to step 3 and find the upper and lower confidence intervals by first finding the error. So to find the error, we are 90% confident. And so because it's 90%, we would do 100% minus 90% gives us 10%, and that 10% changes to a decimal of 0.10, and it is two-tailed, so that would be 0.05 in each tail. And then we look for the Z that goes with that, and that gives us 1.645. Ms. Borlaug does not take time in this PowerPoint to explain how to look for that. So if you need to know how to look that up, you can contact me and we will go over that, but that gives you 1.645. Notice that the Z alpha sub 2 is one number. We do not put the alpha and the 2 in. That just tells us which Z we looked up. Then we put in P hat 0.82, Q hat 0.18 and N of 150. That gives us 1.645 times the square root of 0.82 times 0.18 divided by 150, and all of that is under the square root. When you put that in the calculator, it sometimes looks better to put it in parentheses when we write it, but in the calculator, it will calculate better without the parentheses. And when we estimate that, that then gives us the 0.01. Excuse me, I don't know what number I was reading, 0.052. Miss Borlaug does round that to 3 decimal places, and that is our error. Once we do that, we will add and subtract. I'm going to erase that 10% now. We're going to add and subtract that error of 0.052 to the 0.82. So 0.82 plus 0.052 gives me 0.872. 0.82 minus 0.52 gives me 0.768. And that is the lower and upper, or the upper and lower limits. And step 4, and the final step of this process, is to write a sentence to explain what we have. Remember that your sentence follows that same basic pattern, which is I can say with, in this case, 90% confidence that the proportion, in this case, of customers who ordered their hot dogs with mustard is between, and then we can fill in the proportions. So it's between 0.768 and 0.872. Now you have a class activity. This is a problem for you to try. Ms. Borlaug often uses this one as a quiz, so I will not give you the answer for this in this video. I think I was going to give you the answers to this, but I don't have those. Nope, because I do not. But here's a problem for you to try. If you want to get those answers, you can email me, and you can reach me at beth.dixon@ws.edu, and get in touch with me, and I will help you with this problem if she's doing it. Remember to get full credit, to show all 4 steps of the process, and show all the work involved. Thank you for watching.